Today I would like to, as the last lecture, I would like to talk about what I'm calling human-centric data science, sort of questions about, how data science affects people and how one should use people and not use people and all this kind of stuff. And it's partially triggered by this book. How many people have heard of this book, Weapons of Math Destruction? Okay, it's got a great title on it, right? Weapons of Math Destruction, okay? But what it was written by was a data scientist who, came to understand that there are, obviously there's good things about, data science and good things about computer-driven models. But there are also bad things, and it is a fair thing that people should understand the bad things and be sensitive to these kind of things. If I had to look at you, many of you are going to go off and graduate and go off and work for companies that are going to build big models that are going to be used by many people and can cause a great deal of harm if they are misused in bad ways. And so it's worth talking about these things. I think this is actually kind of an interesting thing. And a lot of what if you want to say what, at least from the thesis of this book, if you want to think about it, is one of the big problems is we know that correlation is not causation, okay? But the models that we tend to train in here quite often are based on correlations. You have features that correlate with something. And so you can learn to create, basically what you could end up doing is creating models that identify people, okay, with certain bad traits based on correlation, okay, that ends up causing them problems, okay. And what's more, can kind of trigger other problems. There's kind of often feedback mechanisms where, if you are something bad happens to you because of this model, other models will think you're bad, and it'll keep getting kind of cascading, okay? So you can imagine a world where if you live in a bad neighborhood, okay, you could imagine a world, because they know that in this neighborhood, you apply for a loan, you're in a bad neighborhood or something like this. There's features that would show that there's poverty around you. Maybe they're less likely to grant you a loan, okay, because you're not able to get a loan. Maybe you're forced to pay rent and a lot of other things, and that causes your credit rating to go down, and there's kind of often cascading effects of these things, and they often end up triggering in kind of what I would call self-fulfilling prophecies. That if you have a model that correlates you with something bad, it's possible that repeated misuse of the model will cause it to bad things to happen. And it's important for us to realize that. Historically, data scientists have kind of thought of these machine learning models as, fairly benign and fairly prejudice-free. But if you train it on biased data, you end up getting biased models. Any questions? So if we were to take a look at this, in this book, she identifies 3 properties of what is a good model, okay? And we can decide whether or not, what are kinds of models, okay? Well, let's think about it. What models do you guys know of that people use data for to make predictions on people? Let's start with this kind of thing. What kinds of models or situations is data used to predict things about people? Okay? A good way to tell, these are the companies that hire data scientists. So is there any company that we can think of that hires data scientists? Yeah? What? Okay, LinkedIn. Okay, you say, okay, so Quora and LinkedIn are relative. Well, Quora is a fairly benign thing because it doesn't really reflect back to you particularly. LinkedIn would be one that's kind of closer to you, but you're usually putting yourself out there, right? So it's a little less clear where to me at least initially, where the bad models are. Facebook is an example of where are there models in Facebook that are. Well, okay, so part of what happens in Facebook, I guess, is there's models that show you what news you're seeing, right? And this is one example of where there is a potential to do bad things. Okay, you can imagine that one group of people sees news that is helpful and productive and informative, and one group of people, the model might show news that is junk. Okay? And I mean, obviously, there's a lot of stuff in the news these days about Facebook's, about bad news and fake news. And was it fake news that was doing it? Why was it that certain people saw these horrible stories? The story the other day was of somebody who just got arrested for shooting up a pizza restaurant. Why did this guy shoot up a pizza restaurant? He read a piece of garbage news that Hillary Clinton violated children in the back of this pizza restaurant. Not that she ordered pizza from it, but this is what she was supposedly doing in the back room, right? And these were, obviously ridiculous stories, but obviously they went to certain people. They didn't go to me, okay? And people saw them and reacted in ways, and this seems like a bad thing, okay? So that's a model for Facebook. What models are there for Google? Does Google do? Google Ads, showing you what kind of ads do you see, okay? And are there ways that Google Ads can do bad things? You may say it's benign, it's showing you an ad. What would be an example of a way, a system that shows you ads?
If you're searching for a bad thing to do, like if you're trying to make a bomb, it can tell you where you can find the parts.
So one question would be, are you searching for things that you shouldn't be searching for, and it helps you find it? That's maybe one of them. But I would say, one class of things that people seem to find is that they've done tests where, when some of these engines that come up with looking for jobs, you type in software engineering jobs, okay, or find me jobs. I want job ads, okay. What kind of things show up depend upon what the bidders are doing and what the models are doing. And there apparently have been studies that show women get ads for less important positions than men on these search engines, okay? And, you could almost imagine how it's happening. It's training on something. The search engine, for some reason, has decided that these ads are more likely to, that there's certain features that correspond with these jobs. More of the people who become software engineers are male. Therefore, if you're male, are you more likely to be interested in a software engineering job? The answer is maybe, okay? And so there are a bunch of these kind of factors that could happen if you let models learn from data. Okay, it doesn't mean that learning from data is a bad thing, but we need to be aware of what kind of problems can come up with models. Any questions about that? Okay, so what is their claim, and how many of you, okay, let's see, a bunch of you guys have applied for software internships or internships in companies, right? I don't know these. How many people have had to take psychological tests for jobs? You did it. What job was it?
Security, I
You
needed a security clearance. So.
needed a security clearance, okay. What was it? So for security purposes. Were there any other tests that people took for getting jobs that seemed weird? Okay, I'm not getting that much.
I know they do like Myers-Briggs and stuff sometimes.
Myers-Briggs are these personality tests. Has anybody ever taken a personality test like that? What was your job for? Epic Systems. So this was you wanted to program for some healthcare provider. And part of what they gave you was this Myers-Briggs thing, which is going to tell you something about your personality, right? And based on this, they're going to partially decide whether to hire you, right? Now, the question is, when we think of, and again, there's going to be these models that are going to take scores from these things and try to figure out, do we want to interview this person? Do we want to make them an offer? Okay? And what are the properties that she would identify of a good model? One is that it uses relevant data as opposed to data that happens to be available. Okay? Quite often on your projects in here, we have a goal we want to achieve. We have a goal, we have data that we've scavenged somehow. And our goal is to try to make it do what it's supposed, do what we want. But recognize that there are kind of dangers in that when you have data that's collected in an ambient way, okay, you could analyze it, not because it's really directly relevant to what you're doing, but because it happens to be available. How many of the people when you interview jobs want to know your Facebook account? Has anyone ever, I hear about people who interview jobs and they want to know their Facebook account or their social media thing. Has anybody ever done any of that?
Consulting firms do.
What?
Consulting firms generally do. They want to see what you've been talking about on social media. Like generally during an interview, they ask you to open your. At least I was asked to open my social media account.
Okay. And so there's questions now of, again, why do they want you to open up the social media account?
Probably because to see what have you been talking about in public? I mean, they want to see this. If you do say anything controversial, what do you follow? What do you not follow?
Okay, and the question I guess that you want to ask yourself is that relevant data or is that data that's available? And depends upon what the situation is, but recognize that there's a difference. You could imagine very much wanting to get as much data as you can about a candidate. It takes a certain amount of wisdom to make sure that your data is relevant to what you're trying to predict. A good thing about a model is when it is what you would call transparent, meaning you're understanding why it makes its decisions. Now if you go to someone at Facebook and you ask them, why is it that you showed me this restaurant about Hillary Clinton doing something illegal in a pizza restaurant? There will be no one at Facebook, presumably, who could tell you this. Okay, it's some complicated model, and it's not clear why it's making decisions, and that seems like a bad thing. You'd like your model to make decisions. Finally, and this is probably a newer one, and one that struck me as more important, was that if you're going to use a model, there should be a clear measure of success and some kind of a feedback mechanism to check whether or not it's doing the predictions you're making from it are good. So, for example, I can imagine this consulting firm, okay, rejecting anybody whose Facebook page has somebody them drinking it from a beer can, okay? Now, the question, I guess, is there evidence that people who drink from beer cans are less, and show it on their Facebook page, are less good employees than other ones, okay? And often there's not really a way, you don't get feedback both ways. Notice that you can certainly take a condition like this and not hire them. And you can say, look, see, we didn't hire these people. But there's often not any good way to tell whether or not you're actually really making a good decision from that, right? If you could later go back and say, let me now look at the people 2 years later who we rejected because they had bad social media accounts, right? And you'll say, oh my God, this one became president, right? Okay, that's a sign of a feedback mechanism. Does everybody see that? Okay, and this is something that is often hard to learn from. Okay, any questions? Yeah.
So, this thing that we're discussing, like the model, we should have the data correct and the model should be correct. I think there would not be anything apparently wrong with the model, the data, right? Like, let's say it is working on some sort of affinity principle that some certain people are talking about certain things and it is showing you something that it thinks to be relevant. So there is nothing like inherently evil about doing this logic, right?
Well, but if you're telling me, let's say that I'm going to try to figure out who's the best student I accept. I build some kind of model where I train on some highly suspect data and come up with a scoring system for who I think is going to be the best student. Have I done anything wrong? It's going to come back with, but there's a garbage in, garbage out principle. If there isn't really a way to evaluate it, okay, again, a lot of the stuff in here, you guys are going to be showing me projects. Many of your projects will be poorly evaluated, right? And, recognize that with a lot of the kinds of models you want to do, like should you hire somebody, it's hard to get the direct feedback of whether or not the model is really doing the right thing, okay? And, you can say, well, okay, use data, and it come up with a decision, and you should listen to the decision. But it's important that there be some feedback mechanism to evaluate and see what it's doing and whether or not you're really happy with these kind of decisions. Any questions? So an example that's on Long Island, right, over the last couple of years has been a very big issue that slowly I warmed to. I'll admit I didn't get sensitive to this till relatively recently. There's a big thing in the United States lately has been about school testing, right? That every schools have state testing, and based on these state tests, they can rank each school, how well are the students in this school doing, and they also have the idea that they can rank teachers, okay, based on if the students are coming out of your class are dumb, okay, or doing badly on the tests. What does that mean? Are you a good teacher or a bad teacher? Okay, and one can make presume that if the students coming out from your tests, your class, are doing badly, don't score so well on tests, that means you're a bad teacher, and they fire you. Okay, and so there is a lot of work on the state testing that they're doing. A large, part of it is to figure out how well school systems are doing. But a lot of what they're using it on is to judge teachers, individual teachers. Does one think that this model is a good model or a bad model? Obviously, I think it's a bad model. But why do we think it's a bad model? Yeah?
Because it conflates correlation with causation. I mean, just because you are finding that there is a lot of students from a class are doing bad does not really imply that the teacher is bad. I mean, those students might already be at a disadvantage as compared to some other.
So there's one question of whether it is a relevant or available data. Again, there is a problem that, of course, if you have lousy students coming into the class, then the test scores are going to be lower afterwards, right? So to a certain extent, it's not clear. I mean, again, students' performance is somewhat related to the teacher, and I would again, I would like to think that in a large enough scale, I think that you could certainly credit the performance of the students to the school system, to something like that. But recognize that when you're teaching very small numbers of students, right? In a typical high school, grade school class, you will have 30 students for a year, right? And whether the average of these 30 students is not a lot of students, right? And whether they do better or worse than average, there's going to be a lot of does everybody kind of see that there's a lot of potential false positives among the teachers whose students get bad grades on these tests? Any questions? I think there's a little pushback or something. I'm not sure I'm making the point here or not.
Well, I mean, you would imagine most of the kids, like if ability is normally distributed or something, and you have AP classes that sort of pull off the best students, then you're really only going to be getting from like the really fat part of the curve, right? I mean, so you would.
Well, the fat part of the curve had the tail of the curve.
Yeah, so you would. I don't know. Would you imagine that there would be that much variation? I mean.
Well, if your goal is, if let's say you set a policy that I'm going to fire the 5% worst grading teachers every year. Okay, let's say I'm going to set this thing up now as my policy. I want to have good teachers. If I could fire the 5% worst teachers every year, would the school system get better? Okay.
Well, I mean, ranking, I think, is the problem. Ranking would be the problem, right? Because small differences could account for large.
So then, relatively small differences in the composition of the students,
Right.
or the composition of the students going in, or the performance going out, right?
But if you did a threshold of some sort where you were like, we expect performance of like this much year over year or something.
So there are, again, one might argue there's ways to make it better, but I would like to think, for example, if you want to figure out whether somebody's a good teacher or not, you might want to ask their peers. I think they would know something about it. Would be extra information. There would be a question of how big a sample do you need for how long, how much control of the, but the problem with it is also that the feedback and evaluation, it is very clear that you can identify on any measure the 5% worst teachers by that measure. Does everybody agree? That's a numerical ranking. Can you find the 5% people with the lowest number? That's very obvious, right? Now, the question is, how do you know that you're firing the bad teachers? Okay? Is there a way to go back and see whether this is really capturing what you think you want, or just are you eliminating the teachers with low scores? Okay? And what I think is the case here is that there really aren't the feedback mechanisms to convince me that these kind of evaluation systems are particularly meaningful. Okay?
So an evaluation for this would be like fire the bottom 5%, and then the average test score of the students in your building goes up.
Yeah. So one possibility is, does the average test score of the students go up? Okay. Or do we find that 5% of the teachers next year are going to have the same problem? Okay, that would be one kind of an issue. Okay, one would be, use other backup measures. Now, how do the scores on this correlate with things like the reviews that, let's say, the students give of how good they think the teacher is? How does this correlate with how do other teachers think about these things? So there needs to be some kind of a feedback mechanism to really convince you that you're really catching the bad ones, okay? And when you read this book, and the way I suspect that the school systems largely work, they haven't really been doing a good job of it. That is, I guess, the moral here. Any questions about that? Okay, maybe that's clear. So what kind of social/ethical issues come up in big data analysis? Okay, and I made up a little list of things I had something to talk about. So what are things that as a budding data scientist you guys should do to be morally good people versus bad people? And one big thing that often happens is, in a data science world, you often know lots of things. You are asked to report to build a model to do something. Often you know what your audience wants to see. Often you know what your model much better than the audience, and you know the weaknesses of your model. Okay? And, it's often very, very easy to hide the weaknesses of the model that you know about, okay, based on, just not telling the person in charge, right? That there's no question that the guy who's running the school system doesn't know anything about statistical significance, doesn't know anything about a lot of things, right? And to a certain extent, it's about the, you have to communicate what you know to the audience. So what are the good practice things that we should do? First, it's a bad thing to just present a correlation, saying, look, my thing got a correlation of this. It's good to present a p-value. How surprising is it also that I got a correlation of this strength? It may be that my correlation is of small enough number of points that it's not very interesting. Or sometimes to prevent a p-value, saying, look, this is significant, when you saw that the strength of the correlation is very, very weak, and the only reason you got a high significance is because n was very large. It is often bad to, cherry picking is a classic thing. What is cherry picking? Does anybody know? Presenting the best thing of what you have, okay? And there's, again, there's a certain amount of stuff you want to brag about, but it's important not to misrepresent yourself based on, the best results. It's important that when you use a visualization that it show off data in ways that people can ask questions. It's often easy to to create a visualization that is not rich enough to encourage people to look at it and to think about it, but just to see a line going up, okay, and saying that's good. Okay? Any questions about that? I guess as I say this is a little bit like moralizing. Any questions? Okay? There are problems about what I would call in data collection about transparency and ownership. So, to a certain extent, the question of, when you're working for an organization, does it have rules about how long, under what condition it will collect data and how long it will keep it, okay? In a, there are problems that there's a natural tendency for any organization to want to keep the data forever, okay? There's natural data to collect as much stuff in your users as you can, and sometimes people don't really represent to their users what they're really keeping or how long they're keeping it. In principle, most responsible companies will have some kind of a data retention or use policy, saying that, we will discard all user data after 180 days or something like that. And adhering to that is a good idea. There is a bigger problem, especially in important models, where there's a question of whether data errors are corrected or not. Okay? You could imagine a world where there's a hiring, some kind of a model that's, let's say, maintaining your credit report. I know none of you have ever applied. Have you ever applied for loans? Yeah, okay. And so what happens when you apply for loans? You at least in the United States, there's typically this kind of credit score that you have that's a measure of how good a risk you are. And, in some sense you apply for a loan and they tell you, oh, you're a 619. Or maybe they'll tell you you're a 432, which is not, and we only give a loan to anyone above a 500. These scores are by themselves relatively opaque unless you can actually look at why they were being made. And in fact, credit data apparently has the property that it is good that you can see not only what your credit scores are, but you can get to, if you can get a look at the whole record to see whether or not there's things on your credit score that can be corrected. Sometimes maybe a company will say these people didn't pay the bill, and they'll say this person should lose credit because they didn't pay our bill, but you were busy suing this company because they were a bunch of thieves in the first place, right? And, the question of whether or not, there are mechanisms for people to correct the data that you're giving them is kind of an important thing, okay? Any questions about that? Okay, and again, there's models that are important. Any questions? Okay, good. This question of, you build a model that takes training data and uses it to provide filters or make decisions are often, there's a lot of surprisingly bad things that can happen from these models. One thing that was funny was on my sabbatical, I was working for a major internet company, and we had to use that major internet company's email instead of what I'm used to seeing. And at the beginning, when you first work for this, get an account from this major internet company, they know nothing about you, right? And so when the question of how do they tune the ads to you, well, they have relatively little information. And what amazed me and horrified me was how horrible the ads that I was seeing from this thing. I was seeing ads for things like, sell your house to us and we'll pay cash and not pay you what you should have, okay? I was seeing, borrow money from a loan shark, okay? We're loansharks.com and borrow money from us at a very high interest and stuff like that. There were a lot of ads here for products that were clearly bad products to have. And I never see these ads in where I normally get. And why is that? My guess is partially because, my profile on these ads is based on once they have knowledge of me and, I'm doing a lot of computer sciencey things. I'm doing a lot of higher brow things, higher economic status things. They show me ads from vacation places. They show me ads from higher end things. And I guess what I was saying is that it was clear that the ads they were showing these people were not good things for people to be seeing. Okay, I don't know if people are following me or not. Maybe I'm feeling a little sloppy in what I'm saying, but and I have absolutely no doubt after that experience that these filters are learning who are the people they should show predatory things to. Yeah.
I also wonder at this major internet company that you worked at, who are people who tend to have those internet or email accounts, probably people who come from a different class background or something, because you didn't work at Google, right?
I was working for a major internet company, okay?
So like, I didn't know about Gmail till I went to college, and like I
Yeah.
feel like that was just sort of like something that peers from like universities or like private schools or everything had known about, but I didn't know about myself. And I wonder, but I did know about the major internet company that you worked at, and I wonder if that's because it's like a class thing, or and that's why maybe you were getting.
Well, what I think part of it is the following, that when they know something about you and that you're, again, how do these ad models work? They're trying to figure out who is the person who will buy the ad for the highest price, right? They have a right to show Skiena an ad, right? And you can imagine that, if you're a computer company, it's worth your money to pay a little bit more to show it to Skiena than to show it to some random guy, right? But who are the ones, when you have the high-value ads taken care of, what is left to kind of show to the low, to show to a lower socioeconomic class? To a certain extent, they're the ads that the major internet company is willing to show at an extremely low price, right? And so there are these kind of, I think, biases that come up just because of the search engine and just because of the economic situation that we come in. I can believe that certain places show better ads than other places, but there is no question to me that the president of the major internet company saw much better ads on their email than I did, okay? Any questions about that? Okay? And, when you do these kind of predictions, it's kind of important to think through these kind of things. There's all kinds of problems with these news filters showing you, if I have Facebook, I can only see articles that interest me. There seems to be real problems with the fact that people, again, I grew up reading a newspaper. A newspaper was a printed thing, and it was sent to 2 million people, and they all read the same newspaper. And now, when everybody reads a newspaper, it's just the stuff that the algorithm thinks that it's good. I'm going to see news stories that they think I'm going to be happy about, okay? And often they reflect one political view, which is probably the one I already have, okay? And again, so these are problems, and it's important to think through these kind of problems. Any questions? Yeah.
Do you think that the Facebook fake news dilemma that is any different than the New York Times supposedly having let's say a liberal bias, or the Washington Post having a conservative bias, or Washington Times,
Yeah.
whatever, the new financials, whatever.
Yeah.
Do you think that there's more concern because it's a platform as opposed to a content generator itself?
My general sense is that, again, I will confess to being a loyal New York Times reader, and I detect more of a political slant in the New York Times now than there was a few years ago. So there is some movement towards polarization there. But I still think that it is not anything to the degree that can be done on an online thing. Because it really is the case that every person is seeing a different thing, okay? When I look at my New York Times, I see, I do have a conservative columnist in the op-eds. Okay, you can question how conservative he is, but he'll call himself conservative, and I'll say he's conservative, okay? But I think that there's obviously more room for mischief with the online things, yeah.
And also, to answer, whenever you have something like a newspaper or something in which there are editors, and also they do have that, they ensure that there is another point of view at least on the table. It's not like they will just have a very lopsided view, at least in the content which has a proper editor. That is the point of having an editor, right? If you just want to talk about a single viewpoint and not see the other side, you don't need an editor.
No. Normally, okay, an editor will normally have, again, the fact that certain newspapers news sources were known for being, liberal versus conservative, okay? That's, but to a certain extent, is Facebook liberal or conservative? Okay, you say not neither. The answer is both. Okay, that's a little bit different. Okay, and my gut feeling is that you don't really know what the bias is. You're seeing your stuff and you're happy with it, and this is the way the world should be. it does seem to, in my mind, I think it does reinforce polarization, okay? And I do imagine that you can, there's no question you can train your news filter to be, I think, a lot more biased than any respectable editor would be. Any questions? Of course, you could also design systems, if you're Facebook, to make sure that you do have a certain diversity in what you're getting in. And that's probably, part of the, let's say, social responsibility of one of these platforms. In the long run, I'd like to think that they will embrace. Okay? But that's a thing to do. Any other questions about these kind of biases? Okay? What is another responsibility for a big data person? And the important thing is security and privacy issues with big data are wildly more important than small data. Again, a major internet company I worked for, had a security breach where a certain number of 100 million passwords were lost, right? Or accounts were broken into, right? Now, recognize that one interesting thing is, one way you could, let's say, make up for that is to tell people, oh, we had a break-in, why don't you go and, why doesn't everybody change their passwords? Now, in this case, this major internet company apparently didn't want to do that because they were afraid they were going to lose customers, and that was part of the scandal there. But notice that if you make 150 million people do something that's going to take 1 minute, which is about what I think it will take to change your password, if you're quickly, that is 190 man-years of effort, okay? So the schmuck who lost who let's say let these people in, used 3 lives, somewhere between 2 to 3 lives of effort just in changing these things. So recognize that, forget whether their data was stolen. Even the effort to make them do something, is a big human cost. Obviously, getting their private data released is a big hit. The interesting thing is many of the private data that they get released, one problem is it's not like it's something like a password that can be corrected, but it's something that will persist forever. If you have released my Social Security number, am I going to get another Social Security number? No, that's it. And now, every time for everything that I'm going to do in the business world for foreseeable future, okay, that is now released, okay, and it's and so the same thing is true with a lot of this kind of information. So there is a need to try to encrypt. It's important that when you are dealing with data, you need to have an encryption process so that even if the systems people kind of let your machine get broken, if there's confidential data, encryption is an important part. And another thing is deleting data when you don't need it anymore. This I know is a very painful thing. But a lot of the times the way these security breaches happen is that somebody builds something, they have a project, they collected this data, they have a directory, then they get their account broken into. And 2 years later, suddenly there's still this data file there with all the interesting goodies in it. So it's important when you work for a real company and you have real responsibility that you preserve these things. Any questions? And a lot of this stuff is really kind of important. There's one thing that's, again, there's apparently as a consequence of the election, there may very well be a lot of changes in how health insurance and life insurance works in this country. And, there become questions of if there's enough data about anybody out there, once there's any data about any kind of health risk that somebody has, suddenly the price of their insurance is going to go way up, or maybe they're just going to get dropped from medical care completely. And, this is kind of a big problem because once it gets out there, it's out there forever. And these are relatively macro changes, okay? Any questions about that? So these are important things to think about if you are dealing with private data. Any questions? Okay? The other thing to note is that one way that people sometimes try to preserve privacy is to deal with data in aggregate. So you say, or you anonymize data, before you release it, okay? Or you just deal with it within some kind of an aggregate set. It's often amazing that people, when they're very clever, can often de-anonymize data in ways that you would be surprised by. There was a story I don't know if I mentioned it in here, about this guy that wanted to release search queries, as a research tool. He took data that was entered into search queries that were entered into a search engine, and he took off people's names and locations, because that would obviously do it. But he apparently left tied together which search queries somebody had issued. So I knew all the queries that this person had issued, and I had an ID number for that person. What people quickly found out is that based on certain queries, you were very often very able to identify who the people were, even though the data was anonymized, right? That if you saw a guy who was Googling from Setauket, I Google weather in Setauket. I Google Stony Brook. I Google Twitter Skiena from time to time, right, to see what's going on there, right? And there's no question that you could learn lots of things by doing it. So one has to be very, very careful about anonymization and dealing with things across multiple data sets. One that I read about that was kind of interesting, we talked about the taxi data in here, where, New York City has this taxi data, and you can find out for every taxi trip where and when did it start, where and when did it end up. Apparently, what some people do is they know from paparazzi photographs that appear in the newspaper. There's often a picture of Leonardo DiCaprio and his latest squeeze leaving the taxi, right? If you know where he was leaving the taxi and when he was leaving the taxi, right, then in principle you can go back and figure out where did he catch the taxi with, right? Where does the squeeze live? Who is the squeeze? This kind of thing. So there's a lot of stuff that you can do if you correlate these things against data sets. Any questions about it? So that's, I guess, the end of moralizing that I'd like to do. This is one of these things. You should be aware of these kinds of issues. Okay, I do think they are important, especially if you are going to work for one of these big internet companies, okay, or a big health provider or something like that. You should think through these things morally, what's right and what isn't, and keep that in mind. Any questions? Okay. There's one other aspect of human stuff that I wanted to cover in here. I didn't cover it back in the section in the book where I was talking about it, but it had to do with things like crowdsourcing. So another way that people use humans, okay, in data science has to do with something called the wisdom of crowds. The question of whether or not you can aggregate data from a lot of different people, okay, to try to learn something more than individual people could know, okay? And so, crowdsourcing is about going out to multiple people, getting work done, and coming back. Wisdom of crowds is trying to learn something from multiple people. There's kind of some interesting properties of this that I think I'd like to spend the rest of the semester talking about, since the semester is only a half an hour from now on, okay? And the whole notion of the wisdom of, how many people have heard of the wisdom of crowds? How many people have never heard of the phrase, the wisdom of crowds? Oh, okay, so that's something. There's a popular book, let's see, I'll prove to you. Look, see a book, The Wisdom of Crowds. This is a big deal, bestseller, okay? Let's come back here. Where it's sometimes this phenomena that a group of people know things that collectively that they don't know individually. That's kind of what I would argue the wisdom of crowds is about. And this was discovered by a guy named Francis Galton, who was a relative of Darwin. Okay, when he went to a livestock fair, they had one of these contests where you had an ox, and maybe they were going to give it, or give some prize to the person who could best guess the weight of the ox, right? Now, if you saw an ox, do you know how much this ox weighs? No clue. But the claim would be that if you have enough people with no clue, okay, that somehow together the consensus of their thing is going to be a better estimate than any individual ones. And so he saw that there were 800 people who tried to weigh the ox. None of them knew the correct weight. but the average of their guesses was within 1 pound of the right weight of the ox. Okay? So there were certain things, that ways that crowds sort of know more sometimes than the individual people. And I tested this when I taught this course last time. I had a big stack jar of pennies that had accumulated in my lifetime in my office. And I had my biology colleague using first-rate scientific equipment, okay, weigh the pennies and compute how many pennies were in the jar. And I had my class ask try to predict how many pennies were in the jar. And I did it under 3 different conditions. And this is kind of going to get us into, I think, some of the distinctions about how you get good wisdom from crowds and how you get bad wisdom from crowds. I had 10 of them write their opinions on cards of paper quietly. And then I wrote these people on the board. These were these 10, okay? So I had 10 people guess how many pennies were in the jar, and I got numbers from 537 to 15,000. But the median of this was 1250, and the actual number of pennies turned out to be 1879. So the median and the median was closer than any other guess. Again, the mean was thrown off by this crazy person and that crazy person. Does everybody kind of see that? But I still think the mean worked out, mean or median was a reasonably good estimator. Does everybody agree? I then had students make the guess where I'd written those numbers without telling them how many pennies they were, but I wrote down the first 10 students' thing on the board. And then I gave 10 other students cards, and I said, you guess how many pennies are in the jar. And all they've done, they've seen these 10 people's guesses. And suddenly these other 10 came out with numbers like this. What do we see with these numbers? They're much closer to what? To each other is, I think, the biggest observation, right? Nobody wanted to be the dork who guessed less than the lowest. And certainly no one wanted to be, my God, these 2 crazy people who were too high. Is that right? So after people saw the guesses, in some sense they were more tightly bunched, okay? But to a certain extent I will argue that some form of, and in fact it turned out that the median, the mean was actually pretty close to what I had actually now, right? But, but it's clear that a certain amount of groupthink set in when they were making their decisions based on other people. Does everybody see that one? I then offered to sell the jar of pennies to anybody, to the highest bidder. Okay? So I had 2 people who were willing to bid on the jar. And they were willing to bid 1,500 pennies and 2,000 pennies. Right? So I ended up clearing $1.21 on the deal. Okay? But does everybody see that in this case they had a stake in the bet, right? And suddenly the stupid answers went away, right? And that, in fact, there was seemingly, once people were willing to bet, their answers somehow magically came out more accurate than other people's. Any questions? So there is this question of what are the properties when you can collect data from a lot of people and you get a more meaningful answer than when you collect it from one person. And this book identified several properties that are good. One is, the claim is that you want the opinions to be independent. Does everybody agree that if you have everybody give the opinions and everybody is, the loudest person in the room is going to have the opinion that everybody else has? Yeah.
I mean, I sort of thought that too initially, but then after seeing the second case, I have a sort of wonder about whether or not it's sort of seeing other people's opinions sort of allows you to more closely target, or like act like filtering, as opposed to just like independent opinions that might have nothing to do with each other and sort of no basis in reality other than your own subjective understanding of the situation.
Well, okay. What's clear is the following. If opinions are completely dependent upon each other, what do you gain from having multiple people do it? Absolutely nothing. Is that right? So it should be clear that if we're going to use a continuity argument, I claim more information will come in from independent opinions than dependent opinions. Okay? But I think that if you want to avoid groupthink, you have to set up a world where the opinions are independent. Okay? Any questions? Another time when you get more insight is when the crowd consists of people who have a diverse background and knowledge in different methods. Okay? The hope is that when you're showing the pennies to someone, how would you go about figuring out how many pennies are in the jar? Who has different strategies? If you saw me, you did this thing and I went thunk, boom. Okay? What kind of thought processes might have gone into determining how many pennies there are, yeah?
Yeah, I just imagine what 100 pennies would look like and then try to stack them. Yeah.
Okay, does anybody else have any other ideas that they would? Yeah?
Volume of a penny and then find out the volume multiplied by.
One might be if you could mentally calculate the volume of this thing. You knew that the volume of this thing was, this was, a jar was like 4 inches by 4 inches by probably about maybe a foot high filled with pennies. Okay, what's the volume of this thing? Are there any other methods for trying to figure that out? I'm sure somebody in there said Skeena's a scrawny guy. He's struggling with the jar. The jar must weigh, must weigh 15 pounds. Okay, and therefore, how many pennies are there? The claim would be that if everybody is using the exact same strategy, you should come up with the same answer, and you don't gain very much. Does everybody kind of get that idea? So you would want a world where you're hoping that people are diverse in their thinking. If they're not diverse in their thinking, it's the same problem as the independent thing. Another situation is you would want to use the crowd in a world where the specialized knowledge is not needed. If you have a tissue sample and you're trying to figure out whether it is cancerous or not, one possibility is I show it to 1,000 computer science PhD students or random PhD students at the university. The other is I show it to my doctor. Which one do we trust more here? Here we trust the doctor, and the reason is because there is specialized knowledge needed, right? And that if you attempt to ask questions of people which do not have a specialized knowledge, that's a bad thing. The other thing is that that you need a data with the property that it can be aggregated. Suppose, let's say that you were going to ask, what would be an example of data you might be able to get from 1,000 people that can't easily be aggregated? Okay. Okay. So when I take a look at this, you guys have to fill out teaching evaluations, right? Now, I want you to fill it out. I want to hear what's doing. On the teaching evaluations, there are some things that can be readily aggregated and some things that can't be readily aggregated. What's readily aggregated? Scores. Is this professor doing a good job? Bad or not? Did he work or not? Did he show up? Those can be aggregated. When they have the feeling of comments, what did you like about this class? That is clearly information that can't be aggregated very much. I do want to hear that. That's not the rule that I don't want to hear it. But recognize that that's a different kind of a world than what you call it, than the aggregatable problems. And I imagine, actually, do people ever fill in online surveys that a company or something like that asks them to do? Undoubtedly they consist of buttons that you push. What do you think of this? And they ask you to fill in comments. How often do you think those comments are read? If it's a big enough survey, I have to believe that they're not read, or they're read only so the guy who's running the survey can find some that say that he's doing great. Is that right? Because, it's just hard to aggregate that kind of a thing and to get a feel for it. Any questions? Okay, good. So, one thing that is kind of an important point is that, again, this idea of diversity of opinion, I think, is an important thing in life. And one of my favorite personal mottos, I always like to say, be an incomparable element on the partial order of life. What does that mean? Does anyone remember what a partial order is? Do you guys ever take a combinatorics class about partially ordered sets or anything like that? A partial order is, okay. Again, I came up with this when I was doing combinatorics as my research area. But think of a directed acyclic graph, right? When you have a DAG. If there's no cycles, you have a situation like this. Does everybody see that? Let's say we have a DAG that looks like this. Okay? Who is the biggest shot in this community? Yes. If let's say there's an edge from me to you means I dominate you. You can't tell whether this one is bigger than this one or not, right? But you can tell that these guys are lower life forms than that guy, right? And so what I want to do is to be this guy. Am I the smartest one am I the smartest, combinatorics person? No. Am I the best looking? No. But I try to be in a different kind of equivalence class of what my interests are and my thinking and stuff like that, so that I can't be compared and sort of, so that it isn't the case that we don't have an edge like that. Okay? Any questions? So trying to be incomparable, I think, is a good thing. Okay? Any questions? And trying to have a different opinion is actually a useful thing. Within limits, okay? Trying to be a contrarian for the sake of being contrarian isn't it. But any questions? Okay. Now, how can we, aggregate things? So we agree that if we have numerical data, probably the mean or the median is a reasonable way to aggregate, scores, like what was the weight of the ox. Which would we think is a more robust thing, the mean or the median, if we wanted to aggregate opinions? My instinct is probably the median here is probably a better idea. It means half the people thought better, half the people thought worse. One bozo, the dumbest person, would really skew the mean, right? But would not skew the median so much. Now, what if you have a classification problem where you're looking at this thing and trying to decide, is it a car or a truck, and you show it to many, many people? Okay? How might we figure out which is the crowd's consensus opinion? Well, this is the exact same problem as, do we think that the president should be Clinton or Trump, right? And that the normal way that you would do this kind of aggregation is by voting. Okay? Any questions about it? Now, in a democracy, we would like to think that voting where every vote is counted equally, okay, is the right mechanism. I think, I'll hold to that, okay? I may or may not. Actually, I do believe that counting all the votes equally is a good thing. In fact, that's one reason why some people are upset about the election, because in some sense, because of the Electoral College, all the votes were not counted equally in some sense, okay? But as a bigger decision thing, how would we want to count up votes? And what is the theory for why democracy should work? There's a theorem called the jury theorem, Condorcet jury theorem, which says that if each voter has a probability of being correct, let's say you're trying to make a decision, and there's a right answer and a wrong answer, under what condition does the majority make the right decision? If you know that everybody is going to be right with a probability p, where p is, if everybody is right with a probability, each person is right with a probability greater than 1/2, then we can argue that the majority of voters will agree, the probability that a majority of voters will make the decision is going to be greater than p. And in fact, you can work out exactly what is the probability that if you sample n people, each of whom is going to be right with a probability of p, what is the probability the majority of the people were right? Okay? And does everybody see what I'm trying to say here? And, what should be clear is if all the voters were, if each individual voter was, the more accurate a voter gets, the closer p is up to 1, the fewer voters you need to make a good decision. But even when p is very, very weak, okay, where if P is equal to 0.51, you'll find that if you have a large enough jury, you can almost certainly make the right decision. Does everybody kind of get that idea? But this converges relatively slowly. If you have 101 jurors making a decision, and each juror is going to be right independently 51% of the time, the jury gets it right only 57% of the time. Okay? You can take a look that as the jury gets large enough, the probability they're right approaches 1. Okay? Any question about that? Okay? And how do you do that? Well, again, what is the probability that you get a majority of people with this vote? Well, you know, the majority is going to be anywhere from half to n votes. What's the probability? This is how many ways of choosing that times the probability of getting exactly h votes times the probability h people getting it right and 1 minus h people getting it wrong. Any questions? Okay, good. There's another theorem related to decision making that is kind of an interesting one, having to do with preferences of people. Okay, that that there are actually, I'm now, as I now do this, I'm now regretting not having it. Does anyone have the book with them? My book with them? Get that out for me, because I suddenly realized that there's something in there. I think I have something in there I want to show. There is a theorem out that's kind of interesting that says that there is no way to something called Darrow's impossibility theorem, which says that if you have a voting system, you design a voting system where you have a certain number of possibilities to choose from, a lot of different classes, you have a lot of different voters. Each voter is going to rank their choices as a permutation. Okay? The claim is that you would like to have a voter, the voting system, satisfy a lot of properties. Okay? You would like it to be the case that you'd like every voter to be able to output any permutation they want. Okay, that's a free election thing, right? If I have n candidates and I have to give a ranking to them, you want to allow the voter to output any ranking they want. You want that when the election system, chooses which candidate is first and which candidate is second in a group, you'd like that to be independent of all the other candidates. So you could imagine in an election here, we had an election where, at least by popular vote, okay, it went Clinton, Trump, who was third? Probably Johnson. Fourth was probably the Green candidate. What was her name again? Stein, okay? What you would like to do is to have an election to have the property that if, let's say, one of these candidates dropped out, that it didn't change the relative order of these three. Okay? If you had a good electoral system that came up with this ranking of who should be first, who should be second, who should be third, who should be fourth, it shouldn't have the property that if you drop a candidate from the list, that the other candidates permute in value. Do we agree that that's something we would want to have happen in an election? Okay, we would like that. We would like to have the property that if A is greater than B, if all the voters liked A ahead of B, then A would win the election ahead of B. Okay? And we would like it to be a voting system that, is not a dictatorship. One way we could have a voting system that is logically consistent is if I ignored everybody else's vote and just counted mine. Okay? So there are a bunch of properties that you would like an electoral system to have to try it. And what is it? What is an election system? If you think about it, an election system is a way of aggregating a bunch of choices. Does everybody kind of get that idea? So that's kind of why it's a relevant thing. Arrow's impossibilities theorem states that it is impossible to design an election system with the property that it has all of these properties. Okay? And I guess if I have my example here, do I have an example in here? This I should have put into a slide. Suppose, let's take a look at this example I should have looked at. That maybe makes it a little clearer. X, Y, Z, this is the voter. Let's say they wanted to vote on which color is the best color. Okay, now voter 1 voted like this. Voter 2 voted like this. And voter 3 voted like this. Okay? Which is the best color if people vote like this, by any reasonable way to aggregate this? Okay? One might be to count this thing up and, you might say that it looks like to me, what is the right interpretation of these permutations? Okay? I think you would should interpret this as probably being a tie. Does everybody kind of get that idea? But what happens if any one of the color candidates drops out? Okay, so we agree that all three of these colors are equal. Does everybody agree with that? But what happens if any one of the colors drops out? Okay, let's say, which color do we want to eliminate? Blue, anti-blue league, right? Now, which is the color that is best? Okay, let me just think about this. Is this actually, hold on, now I'm going to maybe get myself in trouble. First voter, let's think about it. Among first place votes, wait, hold on. Red got one first place vote. Okay, this is not looking very impressive, is it? Well, what am I trying to say here? Okay. Okay. Okay, actually, this is embarrassing. What am I saying here? Okay. By transitivity, this should be a, okay. It should be the case that red is preferred to green. Red is preferred to green by how many voters? Let's think about this. Red is preferred to green by 2 voters. This is, I guess, the point here. Does everybody kind of see that? Whereas green is preferred to red by 1 voter. Does everybody see that? So depending upon how you aggregate the votes, does everybody see that you get a different answer here? Okay? In principle, all 3 of these, by the system that we think we would like to have, okay, would rate these 3 candidates as equal. Does everybody kind of see that? And yet, if one of the candidates drops out, suddenly there's a preference to the two of the other candidates, to one of the other candidates. Does everybody kind of see that? In some sense, the 3 are all equal by the system if there's 3 of them, but if there's 2 of them in the system, suddenly one is preferred than the other. Does everybody see that? And that's kind of the kind of paradox that we see here in Arrow's theorem. Does everybody kind of get that idea? Here we have a property that the relative order of a subset of candidates is not independent of other ones, right? When Jill Stein decided to run, suddenly it changed the relative order of these things, okay? So bottom line is that that there's, that designing the perfect aggregation system is in some sense an impossible thing, okay? And it's just one of these things we have to live with. Any questions about that? Okay, fair enough. What is the other aspect of crowdsourcing that people, of how do you get the wisdom of crowds? One thing that has happened that is a good thing is that, that to make use of crowds of people, there exist these services where you can hire large numbers of people over the internet. Okay, how many people have heard of Amazon Turk? Amazon Turk is this system where you can basically have an API that you can say, call a person. You write a program and it says, call a person and ask them a question and get an answer from that. And you can farm out small amounts of work, like say, tell me your opinion about this, and we'll pay you 4 cents, okay? And you can and so you can get really, in some sense, the wisdom of crowds, okay? Any questions about that? So these services are often a very good way to get data in many data science kinds of things. Often they're good for getting evaluation data. Some of you have tasks that, like you said, like you could imagine writing a system to try to tell whether something is good news or bad news, okay? In order to get a real ground truth, you'd like to have a person read it. If you're a high-paid person, you don't want to spend your life reading a lot of texts and marking them up. Maybe you can go over one of these crowdsourcing services and get someone to do that. Any questions? So let's just talk for a couple minutes about using these kind of Amazon Turk services. One thing in life is that you generally get what you pay for. Has anybody ever used one of these Amazon Turk services? Has anybody answered jobs for one of them? Okay. They typically pay amazingly little money, right? And as a, as a user of these services, usually your reaction is, that's great, I can hire this person and I'll pay them